Now notice what's happening. I have a client for Alice, I have a client for Bob, I have a client for Kathy, and I have two other servers. Can you guys figure out what these servers might be? We still need a server. So what kind of server do we need now? If you're going to relay through a server, we still need that server, right? Doesn't matter whether we are using RMI, whether we're using NIO, that is an architectural issue. Okay. Okay. Why do I need another server? So how many of you have used RMI? Nobody? Okay, RMI stands for Remote Method Invocation. So the question is, how does a process name a procedure in another process? Or name, so what happens in a particular process, you have objects talking to other objects, right? And an object can go and say stack.push, stack.pop. Remotely, what do you expect to happen? I want to go and say somehow remote stack.push, remote stack.
Send some message to the remote and the unmarshal message.
So that's the implementation, right? Somehow if I can know which stack it is there, we can send unmarshal, marshal, some magic can happen. But how do I even name that guy? In a single process, I just get to see, I just have that, I have a reference to it.
Hostname plus a port.
That's what you do in hostname plus port is exactly what you do in sockets, right? How do I go and say stack versus the queue? Or this stack versus that stack?
I mean, I guess if you, for multiple stacks, you have to have some procedure in there beforehand. If the programmers can know like how many stacks there are and say like if there's 5 stacks, you can just refer to them as stack number 1, or if there's not, then you've got to have some procedure to say like this stack has been instantiated and then it's named A, and then from then on the other process can refer to A.
So what you're saying is that somehow the two processes have to agree on some names, right?
Are the remote, is what that other server is doing, are the remote processes registering themselves and giving themselves some sort of ID and saying, hey,
registering themselves, registering objects, saying this is my stack A. Hopefully this name A means something to the client. Here's my stack B. Hopefully this name means something to the client. And then the client goes to that server and says, hey, can you give me some kind of handle for A? And then I'll use that handle to send objects across. Okay? How this all works is a big part of this course. Okay? So that's what this guy is. This is a name server. Okay? We won't need him again. Now we're going to have a server that is just like the other server we had before, but now it's going to be based on RMI and hopefully easier, who knows. We're going to have an Alice client also. And we'll just, this time, just to keep the confusion smaller, you're going to get very confused when you do fault tolerance. Just keep 2 guys around, and here's the consoles. And here are the controllers. Okay, and let's do it without echoing back. Okay, so let's see what happens. I'm going to do a wait for send. Okay, no echo, and I'm going to do a move 50 minus 50.
What's echo again?
Echo is that the server echoes the message it receives from a client. Remember, the server is the one that's relaying data, it's broadcasting data for me.
Yeah.
In one case, if you send me a message, I send it to everybody else but you. That is not echoing.
Okay, echo back to me basically.
It's also echo back to you. Okay? And that's what we want to do when you don't want to do your action till it's echoed back. That is what caused that issue that, the take command was executed in a state in which the process was not when it issued it. Okay? So right now I'm sending data without echoing. Okay? We've seen the notion of echoing. I don't know to show it again. I want to show you now the differences between RMI and NIO. Okay? Now I'm again blocking Alice after each send. Now if I hit move 50 minus 50, how is it going to be different? Sorry. So how do you think the procedure call abstraction may be different from okay, let me not actually block Alice. Let's just make it more thing. Let's go and block the server as before. Okay? Now I'm going to claim that what's going to happen is not what happened before. What happened before? The 50 minus 50 was executed immediately at the client end. Right? We know we had two threads. That's not going to happen now. In fact, now look at the thread also that comes around. It's not that NIO server that we wrote. It is some funny server, and you guys can figure out what this particular thread is. I mean, how many such threads might exist? Saying RMI TCP IP connection, number 4, and it gives you a little address. Okay, let's leave this to a little later and you'll figure out. Notice he didn't move. Moved. Why? There's no echo back.
Some communication with the name server. Yes.
Name server communication occurs before, earlier on. It says, okay, I need a handle to this guy, I need a handle to this guy, and it gets the handles. Then it really executes.
What else did we change?
This is RMI, this is not NIO.
Okay.
I'm not sending messages, I'm calling procedures. I call a procedure in the relayer. So this guy got the move command. It went and said, okay, I'm going to go issue the command to this is a user interface. The user interface issues the command to the model. The model goes and announces to its observers that I have changed. In response to that change, an outcoupler goes and calls a procedure in the relayer saying, broadcast this stuff. It doesn't send a message. It just calls a procedure called relay. And that relay procedure goes and sends the data, calls procedures back in the other guys. That's what's happening. That's the abstraction. The UI looks very similar. Okay, the abstraction has changed.
So the client called a procedure in the server, and then the server announced that it had changed, and then in response to
No, back off.
Okay.
The server has no data, has got no state. The client has some state. Okay, and as it turns out, the client is broken up into a model view controller. Okay, this is a 401 project of mine where the students built that. And the client goes, the UI got the command. The UI calls a method in the model, all within the same process, the same thread. The model goes and says, I have changed. Okay, that's the I have changed thing. Some observer, some communication observer, which we'll call the outcoupler, receives that message and says, aha, you have changed. I know about some friends of yours who might like to know about it, who are in remote parties. I happen to have got the handles to them. Okay? Let me go and let me call a procedure so actually I know about a relayer guy. I'm going to call a procedure in relayer saying relay. okay? And then I'll return. The relayer procedure goes and says, oh, you want me to relay? I know these 5 guys who've connected to me. I have handles to them. In my relay procedure, I will go through each handle and call, here's a message, here's some data, here's some data, here's some data, another procedure. Okay, that's what's happening. So now you guys see why it blocks?
I think might be on the client there are 2 separate threads at least. One is just invoking the remote procedure, and the one is waiting on the relayer to send some data back.
Okay, so you're saying that's what should happen, or that's what happens right now?
That's what happened.
Actually, if that what you're saying was the case, we wouldn't have this problem. So that's there's only one thread right now. That the thread that actually there's one thread that went and made the change, got the model.
So it's busy making the procedure call, and so it's only after it finishes like communication with the server that it finishes the work on its own side.
That's the semantics of the procedure call. When a caller calls a callee, the caller waits for the callee to finish before it does any other action. That is remote semantics. We're going to cheat in the next system I show you, but that is what really happens.
Basically, it's just a blocking there.
It's just blocking.
Okay.
That's what we want.
Okay.
If I go and do what you said, that I go and take that message, put it in some kind of bounded buffer, and I have another thread that services the bounded buffer and send mixed procedure calls, which is what I do in my system, as it turns out, that I'm going to show you next. Underneath, I am sort of firstly making you do a lot of work, okay? Because a procedure call has to be now unmarshaled, made into a data structure that can be put into a buffer, okay? So the naive way of using this is that you call remote procedure calls. So now what's really happened is that my communication abstraction is matching what I want to send. Okay, I'm sending one thing at a time. No size field has to be sent now. It's all being taken care of underneath by RMI. But RMI is also blocking you. Okay, so if I now go and do my simulation test, even with 2 guys, I'm getting confused here. Where's the Alice? Well, I can do it in Bob. Okay, I go and execute. Oh, I should do. Well, it seemed to have gone pretty fast. But you know, this is pretty unreliable. I forget what the times were from before. But you can imagine, forget what happened here. In which case is the loop going to execute faster? An IO case, right? Because we are issuing commands one at a time, right? In here, I have to go wait for the call to go across there, wait for the message to come back, then I issue the next command. Right? Now, it so happens I'm all on one computer, they're sharing the CPU, so I can't really simulate what happens in a network completely. Okay?
Why does it have to wait?
Because that's what RMI is. RMI says that I'm going to call, when I call a procedure, I have to wait for the procedure to end. That means I have to wait for the message to go from my computer to the other computer, wait for the message to go from that computer back to my computer, plus this guy is waiting for messages to go to other processes and back. This procedure is not ending until everything is happening. So I've got, in terms of no mark commands, none of this, worry about what if half of the string is reached, but I've got a performance problem.
So all this is taken care of by RMI,
By
right?
RMI.
We
But don't be too happy, because you'll be implementing RMI-like things. Okay? So you'll understand exactly what's going on underneath. Okay? Questions? Okay. So that's your assigned project number 2.